Thank you. Hi everyone. My name is Florian. I'm working as a software engineer at Facebook. And tonight I want to talk to you about something that I really like since a long time. It's creating applications. Not simple applications, but complex applications that really provide values to the user and that allow people to create things or compute things that they weren't able to do before. So it's something that I really like. And there is another thing that I like, it's video games. That's why I created an open source project called JDevelop. It's a cross-platform game creator where people can create their own games. And by people, I mean anyone, because there is an editor for the level of your games, and then there is some kind of visual programming that I will show just after that allow anyone to jump in and start to create the rules of the game. At the end, the games are outputted as HTML5 games. So it's a software that I created all in C++ back in the years. And this is what it looked like. So you can see that it's an interface where there is the objects on the right that are living on the scene, and on the middle there is the level of your game. And I'm going to show you the visual programming I was speaking about by showing how to add a button, this button that you can see on the middle, in the middle of the screen, and to have the platform that is on the right to go up in the air so that the player can jump on it and then go through the level. So if we look at it, I'm putting the new object and I'm going to the events. Events are like conditions and actions, like if-then, that are launched by the game engine. So here I'm adding a new condition so that the player, when there is a collision between the player and the button, then I will trigger two actions. The first action will be an action to change the animation of the button so that the animation will go from 0 to 1. The animation 1 is the one when the button is pressed. And I will add another action, which is a force on the platform so that the platform goes up in the air. So I'm choosing the platform, putting a force on the Y axis, and then I can just preview the game. An HTML5 game is generated, and I can play to it, and yeah, that's working. So using this simple principle, people are able to create quite a lot of games actually, and things were going all right like this for quite a few years. But at some point, I had a problem. The editor was really getting old. I mean, for example, I had a lot of cross-platform issues with the UI toolkit. The support for macOS and Linux was really bad. Lot of crashes. Iterating on the software was really slow, well, C++. And building the UI was slow and limited to the all UI components that were only on the offered by the toolkit. And honestly, the UX was needing some enhancement, or at least a lot maybe. And the entry barrier was also high for a new contributor, C++ again. So it was time for me to react. And I've been working with React and React Native since a few years at this time, and I was like, cool, the web technology helped me to improve the software. So React is perfect for making complex UI. Or is it really? Can we have, for example, a list of trees of hundreds of elements, dynamic panels that can move on screen, visualization in 2D or 3D, nested dialogues, drag and drop, search, and color pickers and tabs and file trees, and a lot of things that are really needed when you're creating a complex application like a game editor or something that is going a bit beyond the simple forms that we can sometimes do. So in another way, can we make ambitious application using React? And same from JavaScript. It's perfect for most applications, but what if we have already a native code base? I have a lot of line in C++, including things that were quite complex, like a parser for mathematical expressions, and all the tooling that was converting the games from the engine to the HTML5 game. And we can also think of things like simulation, computation, or everything that need performance. Is JavaScript really a good way of achieving this? If we look at the code base of JDevelop, that was this. So it's an application running. It was an application running with WX widgets, which is still a C++ toolkit to create cross-platform interfaces. And there was the core of the software, which is all the C++ classes that are allowing to to manipulate a game, to say that we have objects and we have this list of objects, we have the level, we have the events, and all the classes that are taking all of this game structure and putting and outputting the HTML5 game. So that's the core of the software, and there was, of course, the graphical interface and all the interaction with the file system. So I was like, maybe we could replace all the graphical interface by React. And the file system could be some Node.js or browser adapters to simulate a file system. And we could run it on Node.js or on Chrome maybe, or maybe in Electron, so that we have both Node.js and Chrome in the same application. And so the only missing part is how to reuse the C++ code base. If we were using Node.js only, it would be fine because we could compile C++ and have a native module. Well, it's a bit complicated. But now, what we could use is WebAssembly and have a library that the React.js interface can use to control the game and even output a real game. For those that are not familiar with WebAssembly, it's a low-level language that allows to run native-like, assembly-like code on the web, and it's running in Chrome, Safari, Firefox, and even Edge, I think. So it's running everywhere, basically, even on your phones. The only thing is that you have to compile things to WebAssembly. You're not writing WebAssembly. So writing WebAssembly, you have multiple solutions to do it. The one that I've used is Emscripten. It's a C++ or C to JavaScript compiler, well, now to WebAssembly, that is taking your C++ code base and compiling it to WebAssembly. I will show how I did just after. You have also other things like, for example, Rust is able to compile directly to WebAssembly, and I think that there are other languages that can do it now. And there is even some language specifically done for WebAssembly, like assembly script. It's really interesting. It's a language that is based on TypeScript, but that compiled to WebAssembly. So of course you have to type everything, and it's really low level. But if you want to do something like EV computation or something that you could write in TypeScript using number and floats, well, that could work, and you can get something that is running almost as fast as native code. So in my case, I used Emscripten. To use it, well, it's not that complicated. It takes a bit of time, but basically you clone the SDK and you install and activate all the latest SDK. And then you're getting something called EMCC, which is a compiler that has the same interface as GCC or Clang, which are, the two major C++ or C compilers. And so you can basically take your existing project, replace the compiler GCC or Clang by EMCC, and at the end you'll get something that is a WebAssembly module. And for larger projects, well, that works the same. Things like Automake or CMake, which are build toolchain in C++, can be used. So at the end you have a WebAssembly module that is more or less running. So that's a good first step. Then you need to expose all the classes that are living in your C++ or in your other language that are living, and to make them accessible from JavaScript. So how to do it? Well, if I take the example of my project, we have, for example, an objects container. That's the list of objects that was on the right on my first demonstration. And you can insert an object, get an object, and you have a layout. So it's the scene where objects are living. And you can, for example, set the name and get the name, and it's extending objects container, so it can also have a list of objects. So starting from this, we'll write some bindings using a special language called WebIDL. There are multiple ways of doing bindings. I went for this solution because it was the one that was the basic one, and it's a tool that is delivered with Emscripten. So you write your interface in this language, and Emscripten the tool will create the glue code that will interface between JavaScript and the WebAssembly. So that means that there will be a fake JavaScript class containing the same methods that you've declared here, and that is calling into the C-like function of WebAssembly. So what it looks like this. You instantiate your module that you're requiring from WebAssembly, and then you have GD here, or whatever the name of your module is, and you can instantiate new classes or objects or whatever, and then call methods on it, and that's working well. It's working well because primitive types are automatically converted. So if you pass, even a string is converted to a standard string in C++, and all the numbers are converted to int, floats, or double. So it's on the mscripten page. Object references are converted to pointer or references. So it's mostly what you use already in C++. And the standard output is also binded to console.log. So that means that if you run your code in WebAssembly, you will likely see in your Chrome debugger that you can see the output of your C++ code that is running. So that's running, and you can even use the objects directly in your console, but it's WebAssembly that is running behind the scene, which is quite impressive the first time it's working. So a few things to know. Memory management requires care. I say that because when you create a new object, you have to destroy it, because JavaScript doesn't have destructors, meaning that when your object goes out of scope, the JavaScript object is deleted, but not the WebAssembly part. Let me explain. If I console.log the layout, so that's an object that I've created, I only have an object, a JavaScript object, containing a pointer to a memory in the WebAssembly world. So the WebAssembly memory is just a large array, more or less, and inside you'll see that you can find somewhere in the middle of all the bits that your object is living there, much like it would work as a C++ program that is writing in memory. And if I just delete if I just make my object goes out of scope, then the thing will stay in memory. I have to call destroy to really erase the memory and call the destructor in C++ to free the memory. So in React, you have to be careful, and for example, you can create an object on the component did mount, and when the component is unmounting, you can destroy the object. That's the simplest thing to do, but you still have to remember to do it. Or you can use an effect hook. Don't forget about the array. Another thing to know is that output files can be really large, like 3 megabytes for gdevelop. Honestly, I don't care at all, because it's a large application, and I'm willing for user to wait a few seconds before it's loading. Plus, with gzip, it's like maybe 1 megabyte, so it's a few large images. That's fine. And plus, when I'm not on a browser but on Electron, I don't pay for this price, because my application is already 100 megabytes large. So a bit more, a bit less, that's the same. And the last thing to know is that you better have a set of tests that make sure that everything is working, because these are the kind of errors that you get when something is wrong in your WebAssembly code. So that's not useful at all. And it can happen, for example, if you enter the wrong type of parameters. If you pass, for example, a string or an object, and the WebAssembly is expecting a number, well, that could work. But the other way, if you pass a number or a string while the WebAssembly module is expecting a pointer to something, so an object, then it will try to write in a bad memory, and things will more or less explode. Same if you forget a parameter, or same if you delete an object, if you could destroy, and then if you try to use it, you will use something that has been destroyed in memory, so you'll get a crash. But if you're careful about this, you get your code base running in WebAssembly on your browser. So that's the most difficult part that is now done. And now we can think, okay, we have the core of the software that is running inside the browser. So this is done. We still have the rest of the code base, and in particular, all the interface to redo in React. I say redo because I've started from scratch, deleting all the code for all the interface, and start from scratch in React. So now I'll try to show a few patterns and a few tips that could be useful when you're making like this a large application that is more a desktop application than a web page. So first thing is that if you're creating a complex UI, by complex I mean you can have a ribbon, you can have a property grid, you can have context menus, list of objects, trees, checkboxes, all of it, even a color picker. For all of these things, I didn't want to start from scratch again and remake all these things. I wanted to use ready-made components. So I searched for a component library, so things like Material UI, React Toolbox, or Blueprint. And I think the most important is to check if there is an extensive list of components that you can reuse, if you can customize them if needed. Are they accessible? For example, you want your user to be able to press tab to go from one field to the other, like in a native application. And check the documentation quality, of course. I've used Material UI because it was the most extensive list of components that I could find. And it's super easy to use. Then in your application, you can have some large list to render. In my case, it was a list of objects that can be hundreds of objects long. In this case, a good thing to use is to go to the path of virtualization. For example, using React Virtualized or React Sortable HOC. The idea is that only the DOM elements that are displayed on screen will be in memory. So if you have a large list of thousands of objects, you'll have only the 10 objects that you can see living in the DOM, so that Chrome or any other browser won't slow down when rendering the list. It's pretty easy to use. Let me just show you how to use React Virtualized and React Sortable HOC. If you have an object row and a list that is just iterating on the row, then you can convert it to a virtualized and sortable list by doing this. So you can see that you have still the object row that is wrapped into a sortable element. Same for the list that is wrapped into a sortable container. And in between, we have the object list, which is a list. We're not iterating manually on the list. We're calling list from React Virtualized. And we are passing a renderer, so that React Virtualized will see where you are in your scroll position, and will only call the renderer for the rows that are to be displayed on screen. So using this, you can get something that you can drag and drop, you can reorder elements, and it's virtualized. So you get the best thing that you could opt for. Then next thing is that you may want to have panels or resizable editors, meaning that, in game editors or large applications, sometimes people want to personalize their workspace. They want to have a panel on the right, but they want to put it on the left because it's more suited to the way they work. So to do this, I've searched a bit and found this styling library, which is called React Mosaic. It's done all in TypeScript, and it's really impressive. Look at it. You can basically have a workspace that you can customize, and I think it's maybe even better than what I've seen in native applications. Next thing is that sometimes you have large trees that you want to render. In my case, the trees were these trees of events. So an event can have condition and action, but it can also have sub-events. It's like a block in programming, and a sub-event can have a sub-event, and so on. So to show this large table of events, I used to do something, it was 2000 line of C++ in the native code base, and I wanted to do the same using React. And here again, I've seen that virtualization was useful. So there is this library called React Sortable Tree that displays more or less what I want from the beginning. I've customized it quite a bit, to be honest, and maybe at some time I will redo it from scratch, because sometimes when you're drag and dropping things, it's not working so well. But still, everything is virtualized, and the way it's done is quite interesting. Every node that you see on the screen is actually a row of a list, and they're simulating the links between the nodes, but it's still a list that is virtualized, so it's fast. And maybe the most complex things that you can maybe have in an application is a custom visualization. For example, here it's the level of a game. And for level of a game, you cannot really rely on the DOM, meaning that maybe it's a good idea to go to the WebGL path. In my case, it was natural because the game at the end is outputted as an HTML5 game running on WebGL. So why not do the scene editor using it? So I've used a library called pixie.js, which is a really performant and easy to use library. It was inspired by how it was done in Flash back in the days, but now it has evolved quite a lot. And there are other really good library like Phaser, it's a game engine, and 3.js for doing 3D rendering. So all of this by using WebGL, you can get something that is really performant. I can't really see the difference between the old and the new app using them. Sometimes still the DOM can be useful. For example, I have an editor when I create the polygon, that is the hit mask, the collision box of my objects. And in this case, I've simply used an SVG that I'm rendering on the top of the object, and using things like on mouse move up and down, I can allow people to drag and drop the vertices of the polygon. Actually, you can use on pointer move so that it's working on touch screens. Let's continue with things that could be useful when things are not fast enough. So it's easy to run into performance issue still, and one of the first things to do when your application has this laggy feeling is to profile the rendering of your components. So using the React profiler, it's quite easy to see when you're doing an update, when you're clicking on a button, all the components that are re-rendering on your page. And for example, here I was closing the project manager. It's a panel that is on the left. And when I was closing it, the whole application was re-rendering basically. So there was a 1 second lag. And so it's quite easy to see everything that is colored is something that will be re-rendered. And my project manager was only this part of the application. So that was the rest of the application that was re-rendering. The solution was fairly easy, using short component update or memoization. Then you'll make sure not to re-render things if the props have not changed or depend on your condition. So in my case, I was checking that when the project manager was closing, it wasn't changing really the state or anything. So using a pure component, I could stop the re-rendering. Be careful, be sure to measure the performance in production, because another time I was profiling something that was not rendering fast enough in the list of events. And when I built for production the app, it was super fast, like a few milliseconds compared to 1 second when I was developing. So make sure to be in production. Sometimes things can be slow because of your call to WebAssembly. So WebAssembly is fast, but the call to WebAssembly can have some overhead. For example, if you have a list of objects that you're rendering, you're iterating on the objects, and if my object here and get type or get variables are WebAssembly methods, then I will pay the price to go over the bridge between the JS and the WebAssembly world every time I'm calling those functions. If I have 1,000 or even hundreds of objects and every call to WebAssembly is a few milliseconds, at the end it's almost 1 second. So it won't be noticeable in most UI situations, but sometimes it can be a good idea to make sure that you're not calling too much of these methods. And if you have to, it's maybe a good idea to store things like, for example, the name of the objects or the path to a file name or whatever on the JS world, so that you can just so that you can avoid calling WebAssembly every time you're re-rendering your list. At some point, your code base is growing, in particular in a large application like this, and you may start to have new contributors, and things can get a bit out of hands. So the first thing that we'll say is to stick to your components. If you're making a help button, you're using the flat button from Material UI, for example, you add help, and then you're like, okay, maybe the help button should be a bit smaller, so I could just add a font size 12 or whatever CSS class. And I think that at the end, this kind of quick hack won't scale in your application, because people will start adding their own help button with a font size that is slightly different, or when you want to refactor this, well, that's a nightmare. You have to go through the whole application. So the idea is just to make a component for it, make a component for everything. Using React is a few lines for making a new component. In a way, what I'm saying is have a design system and stick to it. There is something that can help you to make a design system. I will talk about it. Another idea is don't unit test your components. Well, actually do a bit of unit test, but only for the part where there is some logic. I don't have a lot of unit tests actually in gdevelop. I do have lots of unit tests, but only for the core, the C++ part, that is really containing all the logic, the business logic. For the visual component showing a dialogue, and for example, showing the properties of the game, the name, the author, and the size of the window, I don't have a unit test for it, but I have something else. I have visual stories. So using Storybook or React Style Guide List, you are able to create a list of all your components in your application and to have visual test cases in a way. So the idea is that rather than making a test that won't provide a lot of value to you, you create a story in Storybook, and then you can go through all your components. And that's really useful if, for example, you're upgrading to the new version of Material UI, or you're making a new refactoring that is breaking everything. You will see quickly in a few seconds if something is broken. You go through your component and you see if something is badly broken or not. And things that could not be seen in unit tests, like, for example, the button is rendering slightly different, so it's breaking some layout. And one final advice would be to use types. So depends. I started without types on my project, so it was plain JavaScript, and I then added Flow. It can be Flow or TypeScript, whatever you like. I use Flow because I was used to be using it in React Native, and it's well, types can be sometimes like feeling a bit like adding too much. Adding robustness, but too much to your application, and it's starting to be you're feeling slow when you're writing your code. I think that at least if you add types to the props of your components, you will get useful information. For example, if you're refactoring your component to change the name of a prop or whatever, these things happen all the time when you're coding, then you will automatically get a list of everything that is broken in your application. That's super handy. You can go and fix them, and if you're using Flow, you can actually go and not fix them and just test your application and then fix them when you have the time, before committing, of course. It can help auto-completion, avoid most silly mistake or mistakes that are not yours but one mistake from other people. It can help to document your objects. So in a way, types are getting really useful not when you're writing them, but later, in a few months later, when you'll have forgotten, when you will be someone, you will be like a stranger to your own code, and at this point the type will be there to save you for doing silly mistake, or to tell you this object is this type and you cannot pass this other object because, oh yeah, it's mostly the same but there is a slight difference. So they really shine a few months later when someone else, and the someone else can be you, is working on the app. So I think that using this, we are able to both have the core of the application in a WebAssembly and to use it in a React and have something that feels like an application. Let's just finish by looking at how we can package the application. There are a few options. I used Electron, but you can, for example, make just a web app. There is this application, squish.app, that is made by some guys at Google, and they're showing how to use WebAssembly on a mobile application. It's working quite well, and it's open source. It's a really small application. In my case, I use Electron because I wanted to have some application that I could bundle and distribute as a downloadable application. And you can even go to the most complex way of building your things, and you can use Chromium embedded framework. So, for example, Spotify or the Steam chat are done using this. It's a native application. So if you have a native application, you can use the Chromium embedded framework to have a web view showing in your application, so that you can keep having a native application but show all the interface in JavaScript and HTML. That's what Spotify is doing. Something that I will advocate for is that if you have the possibility, for example, if you're running on Electron, you can override, for example, the Material UI menu and display a native menu instead, so that your application feels more native and less webbish. So I won't show exactly how to do it, but basically, you create two classes implementing the same, two components implementing the same interface, and you're either using the components from Material UI or calling into the native API from Electron. So you get for free something that is running on the web and running in Electron. And using this, I think that we have everything. So let's see the result. That's the new application. And here I'm doing the same thing as before. So I will be adding an object that is a button, and I want that when the player presses it, then the platform goes up in the air. So here I'm even creating the button. I will rename it to be button, and then I will work to add the events just like before. So I'm putting it on the screen and then going to the events. So you can see that the interface is mostly the same but different. And here I'm choosing the collision event between the player and the button. And then I will add the two actions just like before. So the first one this time will be to add a force to the object so that it goes up in the air. And the second one will be the action to change the animation of the button so that is pressed. So all of this is React.js using Material UI, calling into WebAssembly to store everything that is related to the game. And when I press play, WebAssembly is compiling this to an HTML5 game, and we'll get the same result. So the last question is, what are users saying? I will be honest, the first time I've displayed the new version as a beta version, people weren't happy at all. They were like, oh yeah, that's a new application. It's not, they weren't happy because it was a new application that was not having all the features of the previous one. So they weren't happy because of Electron, React.js, WebAssembly. They weren't happy because it was missing features. And after 1 year, 1 year and a half of upgrading it, then they're starting to say that, well, what a difference a year can make, or even that things have become easier, and they can even feel more productive on the new version than the previous one. So I could say that it works. And it works really well, maybe even better than what I did in the native world. Because now I can iterate ultra fast on my application. It's using React.js, I have Storybook. So in 1 second, I can see the change I have done to a component. I can have a cross-platform compatibility that is almost perfect. I have faster startup time. It's like maybe 2 seconds to launch the software, auto updates, more contributors. We can even try it online, so that I can launch the application online and see, okay, try it. It's taking 2 seconds, 3 maybe, to load. And maybe later I can port it on phones or tablets. So yeah, that's it. Feel free to ping me if you want to speak more about something that I told. If you don't agree with something, let me know. And you can check the application, and it's an open source software, so you can go on GitHub and see how it's done. There is a separate repository for the Emscripten part. And I think that's all. Thank you.